let's move on to the second step, which is understanding the flow system. And so let's get ready as if we have a cow coming into the chamber. So first thing we do is we make sure the safety door, this is an electromagnetic switch that opens up if the power stops or if the CO2 level gets too high. So we close that up, and now no power on earth is going to undo that until the electricity goes off. So the door is shut. We've got our cow in there. When we're ready to do the experiment, we usually put the feed in, we shut the door, we have the exhaust fan going that is pulling maybe 500 litres per minute. We close the toggle valves. Now the cow is trapped, but I forgot to turn the fan on. But now air is coming through here, and that air will be a combination of the air that has been drawn in around the cow's neck. There's a loose fitting collar or shroud that we'll see in a little while. So the air is coming around the cow's neck, mixed inside there, and coming along here. And we're going to need you guys probably to come over this side for photo. So this is our air, maybe 500 litres or half a cubic metre per minute flowing along here. We should have had a little filter up the top to make sure the air is clean, because here is an airflow meter, and it is recording the speed of the volume of air flowing through per minute, or per hour in this case. And as the air flows through, we have recorded the flow rate at the start, and we record the total flow at the end of our time. Different flow meters have different principles. These are turbine flow meters, and they in effect count a volume of air. There's a turbine inside that rotates. Every rotation is a certain volume of air. So our flow meter is there. When you put a flow meter in, it does not matter what sort of flow meter, you need to have a straight portion of pipe in front of it and a straight portion of pipe coming away from the flow, so that the flow is linear. All of these things require pretty linear flow to rightly estimate airflow. We have a sampling port here. That is where we are going to collect our subsample of gas, and I'll come back to that in a minute. But the other thing we have is this junction here. Here is, or we can use this one as the example. Here the air is coming along from the chamber and getting drawn down to a pump that we will look at in a minute. But somehow we need to control the airflow to get the flow we want, which in our case is typically 500 litres per minute. And the way we do that is, let's imagine it's pulling 700 litres a minute. We want to lower it. What we do, there's a little T-piece ball valve here. It could be a gate valve. And it is easier for the air to come here than it is to come all the way from the chamber. So if I start to open this, the flow rate here will drop. And when it drops to the value we want, we just leave that alone. And we are confident that it is pulling the right volume that we want. So we've got our airflow from the chamber. We've got a flow rate measurement. We need to be careful whether that is temperature and pressure corrected. So we must know the temperature and pressure of the air that we are measuring, or we will not be able to convert the methane production into grams per day. Okay, so we have our airflow. We are ready to get our sample collecting. So here we are back on chamber 1. We have got this set so that there is a sampling line going down to this, which is a miniature peristaltic pump. And the miniature peristaltic pump is connected, or should be connected to a bag that is evacuated. So this bag should be clean. It should be flushed with to make sure there is no residual gases in it from the previous use. And we can turn on this peristaltic pump. It might already be turning, I can't see, no it's not. So we lock it in, put the pressure on the system, and I would turn it on if I could. Doesn't matter, there's it. Thank you. And we know that we have set this to suck at about 2 mils per minute. And that 2 mils per minute, as soon as I open this bag, will start to get pumped from here. It'll draw it down from the sample line through the peristaltic pump and into the bag. So when we come tomorrow morning after 23 hours, that bag should be nice and puffy like a pillow, but not pressurized like a balloon. So we have our air intake and stocking filter at the top. We have our flow meter. We have our sampling port. The only thing we've not explained to you is where is the fan that is pulling the gas through. And maybe Dr. Sath, you could just point out down the bottom of this trolley where the pump is that is drawing the air. It doesn't matter which one you pick, they're all the same. Yeah. So these are things called side channel blowers, and they are happy to go continuously for months and months and months without being turned off. So it is no problem for them to run for a week doing an experiment. These side channel blowers, if I was buying them again, I would buy ones that could pull maybe 1 cubic meter per minute for a cattle study. We don't want that high, but sometimes it is helpful in say highly humid situations to be able to increase the airflow to reduce the humidity inside the chamber for the cow. So there's our components. The intake line, the correctly proportioned straight length of pipe, the flow meter, the sub-sampling point, the peristaltic pump, and the gas bag that we will collect and take and analyse tomorrow morning at the animal house. While I'm saying, I should say, it is just as important that you measure the methane concentration in the air that is going into the chamber as the air that is coming out. So we have got it all still wrapped up in a bag here, but we must set up another sampling bag up here that is collecting air from around the back of the chamber where the cow is, so that we get a sample of background air. Because in an animal house there might be 2, 4 or 8 parts per million of methane, and we need to allow for that methane going into the chamber as well as allow for the methane that's coming out from being produced by the cow. So I think that is pretty well our airflow system. Filters are important and not present here. And I think when we talk to the other experts, we'll find many people do not collect into a bag, but they have an automated monitoring system where this just goes to an analyzer and it measures it now. It measures it in quarter of an hour, half an hour, 45 minutes, an hour. So many people, instead of getting one gas bag to analyze, they will get maybe 80 or 100 samples monitored over the time, and they will average that to get the average methane concentration, whereas we get the average methane concentration over the day by sampling one bulked sample. And I think I've probably said enough. Thank you. So whenever we are doing things with gases, we need to know the temperature and pressure. Sometimes the machines will monitor it and allow for it, but in this case it is a very manual system. So we have a very simple temperature and pressure gauge, and what we do is we simply, we can do it many ways here, but we will put our temperature and pressure gauge onto the pathway here, and it will tell us the temperature and pressure of the air inside the flow system. Normally it will be about 100 kilopascals, 1 bar. Particularly if you're close to sea level, it's generally not very far away from 100 kilopascals. But we need that exact measurement to get exact methane production rate. So always get our temperature, always get our pressure. And at this laboratory, they tend to measure that temperature and pressure 3 times a day, because obviously temperature goes up in the middle of the day, comes down again at night time. So if we want an average temperature and pressure for the day, we measure it a number of times and record it. Okay, thank you.
Thank you. My name is Widodo from Indonesia. And we have in Indonesia a Cybel system produced by Cybel System America, and that's automatic sample. So we have 4 headboxes in Indonesia, and that measure sequentially with the headbox and the background correction, and it can be measured during 24 or 48 hours automatically, and the data will be stored on our computer, and the gas will automatically analyzed by the gas analyzer, such as the methane and the CO2. So we don't need to collect the sample manually and analyze using the GC, for example, but the gas will be automatically analyzed during the process.
I think that for the whole day, the temperature is different from the morning to the evening. So what happens if you take one sample per day?
So just to clarify, the bag is collecting all of the time. So in Thai, Vietnam, Philippine system or Jakarta system, they sample every maybe 15 minutes and get many individual readings. What this system does is sample continuously. So we are getting every moment of every day being collected into that bag. And we have done many comparisons. They are never more than 2% different than you would get if you did the multiple collection, many sampling points. So the overall average for the day is the same, whether you collect one bulk sample. You cannot just collect one sample for 5 minutes. That would never work. But we collect all the time for the whole day. The other thing that is important in there was you mentioned temperature and pressure. Let me say, if you are making your own temperature and pressure measurements, the more is better, but we have found 3 gives us a pretty good average for the day. Let me just say one thing about pressure in particular. Because we live on the Internet of Things, here am I in Phnom Penh, surely I do not need to measure pressure. I can get it from the internet, from the Bureau of Meteorology or something. Let me tell you that the Bureau of Meteorology in your country, it doesn't matter what country it is, will show you the air pressure at Phnom Penh, at the post office or the airport, wherever they measure. But the number that it gives you is a corrected number. It is corrected to sea level. So the number will always be about 100 kilopascals or 1,000 hectopascals. But it is not the number you want. If you are going to go to the internet for your pressure, you need to, there's a correction equation that allows for altitude. The Bureau of Meteorology, they bring all the pressures down to what they would be at sea level, which allows them to draw those lovely graphs of high and low pressure moving across the country. But the number they give you is not the absolute pressure. So for instance, I live in Australia 1,000 metres above sea level. The absolute pressure in Armidale is always around 90 kilopascals. But my Bureau of Meteorology tells me the pressure today is 101 kilopascals, because that is a pressure that is expressed at sea level, not at 1,000 metres where I am. And the measurements I'm making are at 1,000 metres. So I'm sorry that is a big lecture, but when we think everything is available from the internet, the number that it will give you for the pressure is not right for you to use in your calculations. If you are trying to use pressure and volume to work out the amount of methane, it will give you the wrong amount by 10, well, in my case by 10%, in Armidale. Sorry, that was long. Thank you, Nom.